Welcome to the next video in the series for the AP Calc Summer Assignment Packet. This video is on Section L of the packet, which deals with problems pertaining to right triangle trig. Okay, so we're now kind of finished with the algebra review, the strictly algebra review from the packet. Now we're going to start drawing our attention to some of the trig that we need to do to be successful in AP Calc. So I started out by giving you some problems related to right triangle trigonometry, okay, and unit circle trigonometry. You need to know the different definitions of the 6 trig functions. And what I mean by the different definitions, I mean, for instance, you need to know things like SOHCAHTOA for sine, cosine, and tangent, and realize that cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent is the reciprocal of tangent. You also have to remember that in terms of the sides of a right triangle in the unit circle. And what I mean by that is you should have seen sine defined as y over r in the case of this being your right triangle. There's your theta, there's your y, there's your x, there's your r, and then you're given a coordinate xy on what's known as the terminal side of theta, which is this side here, the hypotenuse of the right triangle. Cosine then would have to be x over r. Tangent would be y over x. And then, like I said, the other 3 come from the reciprocal identities. This is the reason why I wanted you studying these over the summer. The reciprocal identity for sine is cosecant. So then we can say that cosecant is r over y. We can say that secant is r over x, and cotangent is x over y. Here's where that's going to come in handy. If I give you a problem, or I give you the coordinates of this terminal point. So what if I say that the point P, 1, 3, is on theta's terminal side? What are the 6 trig functions for theta? So we have our picture. We have our theta. We have our right triangle. Here's our terminal side. This is the coordinate 1, 3. Okay, so since x is 1, this leg of the right triangle has length 1. Y is 3. The vertical leg has length 3. And I don't know what the hypotenuse is, so we'll call it r for right now. But since it's a right triangle, we can figure out the value of r by using the Pythagorean theorem. R squared is 10. R is the square root of 10. I know r, I know y, I know x. I now can get my 6 trig functions. Okay, let me erase a little bit here just to get some space because I don't want to advance to the next slide. So, sine of theta is going to be y over r, which is 3 over the square root of 10. And if you look at the directions to the summer packet, I tell you, you do not have to rationalize your denominator. On the AP exam, they really don't care so much about that. So I'm not going to be as stringent on that as I was, let's say, in Algebra 2. 3 over root 10 is fine with me. If you wanted to rewrite it as 3 root 10 over 10, that works as well. Cosine theta, then, is going to be x over r, which is 1 over root 10. Again, you can leave it like that, but for the sake of just, reinforcing that root 10 over 10 means the same thing, I will write it that way. And then tangent of theta is going to be y over x, which is just 3 over 1, which is 3. Now to get your other 3 values, secant, cosecant, and cotangent, we're just going to use the reciprocal identity. So like I said, the reciprocal for sine is cosecant, so I'm just going to take root 10 and 3 and flip them over. That's root 10 over 3. Secant, I'm just going to take my cosine and I'm going to flip that, and I get root 10. Cotangent, I'm just going to flip tangent, and now I've got 1/3. So that is the 6 trig function values for this theta, given the fact that 1, 3 is on the terminal side of theta. Let's look at another type of problem involving right triangle trig, where I give you a trig value, for a certain theta, and I want you to get me some of the other function values. So here's what I mean by that. You might see a problem like this. It says if secant theta is equal to root 3, find sine theta and tangent theta. Okay, so first thing we got to talk about is we got to figure out which quadrant theta is on, because that's going to help us determine whether x and y and r are positives, negatives, and whatnot. Well, since I know that secant is a positive value, that means theta has got to be in the quadrants in which cosine of theta is positive. So theta must be, let me just write what I said, where cosine theta is positive, because remember, secant and cosine are reciprocal identities of each other, so that would mean if secant's positive, cosine must also be positive. So cosine is positive at quadrant 1 and quadrant 4. So what does that mean? That means that sine and tangent might be positive or might be negative depending on where theta is. We've got to basically look at both examples. We've got to think about the case of when theta is on the first quadrant and when theta is on the fourth quadrant. So, let's start by coming up with what x, y, and r must be. If secant theta is root 3, well, that means by definition, r's got to be root 3, and x has to equal 1. We can use that information and the Pythagorean theorem to figure out the value of y. Okay, so r squared has got to be 3, x squared is 1, that makes y squared 2. So we take the square root of both sides. Y can be either positive root 2 or negative root 2. Notice I've got to have both positive and negative because, again, theta can be either in quadrant 1, in which case y is going to be positive root 2. You'll have a right triangle that looks like this. Or you can have a right triangle that looks like this, in which case y is negative. So you've got your positive root 2 and 1, and you've got your negative root 2. So we have two different possibilities of where theta can be. It could be in the black right triangle or the pink right triangle. So then that means sine of theta can either be positive root 2 over root 3 or negative root 2 over root 3, which means it's going to be plus or minus root 2 over root 3, which is plus or minus root 2/3. Same thing with tangent of theta. Tangent is going to be y, which could be either positive or negative root 2, over x, which has to be positive 1, so plus or minus root 2 is the value of tangent of theta. And again, we can have two answers, because as I said, given the fact that secant is positive means we have two different possible thetas. One that lies along the first quadrant and another one that ends along the fourth quadrant. Okay? So this should give you enough motivation to do the problems related to right triangle trig. I know a very short video like this can only scratch the surface of a whole semester's worth of trig that you've done, but this at least will give us a nice beginning to start off with next year. Thank you for watching, and best of luck on the packet.